Welcome to Meki Study Circle channel. In this video, we shall see how to create a part using the Solid Edge software and also prepare its orthographic projection views using the draft. Okay, so now we will see how to create this part which is given to us. So the basic observations tells us that it is a part which is composed of a rectangular protrusion and also a cylindrical protrusion. So coming to the dimensions, you can just see that it is having a cylinder of height 60 mm, and then it is having a through hole which is having a diameter of 30 mm, and then the outer diameter of the cylindrical circle is 50 mm. So it is a cylinder of base diameter 50 mm with a height of 60 mm and also having a through hole of diameter 30 mm. And also you can see that on the outer periphery of the cylinder, there comes a rectangular protrusion to a distance of 70 mm from its center. And then towards the extreme left of this rectangle, I've got a semicircle which is having a diameter of 50 mm because the total height is equal to 50 mm. Correct? So this is the observations that we can make. Also, there is a through elliptical hole of radii 10, and the center distance between these two is equal to 25, and the thickness of this is equal to 20. So with this observations, let us try to create the 3D part. So this is the direction in which the observer is going to look. So in the front view, I'll be able to see it as a circle towards the extreme right with two concentric circles, and also a rectangle with a semicircle towards its extreme left with a elliptical hole as shown here. So this will be the front view. In the top view, it will be looking as a rectangle with a rectangle protrusion. In the side view, you will be able to see the observer will be able to see this length and overlapping by a rectangle of block 20 mm cross 50 mm. So these are the observations. So now let us see how to create the 3D part model. So we'll begin with selecting the front plane. So let me generate the rectangle first. So in the front plane, let me draw a line of 70 mm length of 0 degrees. And from here, I'll be drawing a line of say 50 mm. So I'll complete this rectangle, which is 70 cross 50. Now I'll take the circle option and then complete the semicircle, which is towards the extreme left of the part. So I'll be trimming this lower half of the circle. So you can just see that it is not exactly coinciding. So we'll just check out with the dimensions. This is equal to 50. So let me take the circle option and then ensure the diameter of the circle is 50. So now it is exactly coinciding. So now let me take the trim option and trim the lower half of the circle and also this line. So now this part is ready. So now I can also start off with the two circular holes to form the elliptical hole as shown in the part diagram. So this is the center point. So from here it will have a distance of 25 mm. So let me draw a circle, two circle on the same center line. I'll draw the circle of arbitrary diameter and then using the smart dimension, I'll assign the exact value. So the circle is having a radius of 10 mm. So that means the circle radii will be equal to 20. When this circle will have a radii of 10, so a diameter of 20 mm. Then using the line option, so from the center, I will draw a line tangent to this circle. So you can just see the tangent symbol there. So you get to see the tangent symbol. So now let me select the trim option and trim this and this part of the circles, correct? So you can just see that the profile itself is already showing the cutout. So Let me extrude this to a thickness of 20 mm. So now you can just see that the left side of the part is ready with a height equal to 50 mm and the length will be equal to 70. So from this edge to the center of the circle, it should be equal to 70. So now we'll create that. Okay, so now let me select the front plane, select the circle option again, and then this is the midpoint of the edge. So from here, let me draw a circle of diameter 50 mm again. So now I'll select the entire circle and then uh, protrude this. So here, click add and then extend this to a distance of 40 mm. So take the front plane again and then on the same center point, draw one more circle of diameter 50 mm. Select this circle and extrude this to this end to a distance of 20. So now the total height of the cylinder is 60 mm. So take the front view again, select the circle option, and then draw a concentric circle. That means this circle will also have the same center point of the previous circle. So draw the circle of diameter 30 mm and select this particular circle. And then this is a cutout. So go for through all and indicate the direction. You can just see that the part is ready. So this is how you create the 3D part. So select the front plane, select the distance. So this is equal to 70 as given in the part diagram, correct? So this is the front view of the part. This is the top view of the part, and this is the right side view of the part. Correct? You get to see this. So this is the right view, and here this is the front. So in the left side view on the right plane, you'll be able to see it like this. So a rectangle over one more rectangle. Correct? So this is how the part is going to look in its left side view. So this completes the 3D modeling. So now let us save this part file to generate the draft. So now select a new draft file, isometric draft, and modify the sheet properties. Change it to A4, untick show background, click on save defaults and click OK. And now fit the sheet to the screen. In the home window, select the view wizard and then select the part file, click open, ensure the scale is 1:1. So this is the front view of the part which is generated. This is the corresponding top view, and this is the left side view in the right profile plane. So this is the isometric view of the part which is not required for us. So now we will complete the orthographic projection by drawing the reference planes. So select a line of thickness 0.13 mm, draw the XY line. So from the point of intersection, draw a line of minus 45 degrees. So the angle is minus 45, not the length. So now let us fix the front and the top views. So this is the projectors. So the dotted lines indicate it is a through hole, and this is the extreme left projector, completing the total height of the part. And then you can just draw a line from the center to show that the center of this part is exactly lying on the origin of this circle. Correct? So this completes the front and the top view projected. So now let us take the side projection. So draw a horizontal projector on the top and the bottom extreme corners of the part of the top view, and then generate the vertical projector line. Now draw the horizontal projector from the top view So it is taking the reference of this line automatically. So now select the side view, select the move option. So ensure the copy is off. Select the extreme bottom left corner of the side projector and place it here like this. Correct? So you got this. And now select the extend to next option and extend this projectors. You get to see that they're meeting at the extreme corners. And even these projectors can be extended to get the profile of this hole here in the side view. The dotted lines indicates that it is a through hole. So you can just see that this is a through hole of diameter 30 mm and a length of 60 mm, correct? And this is a through hole which is shown here, correct? So now we'll go to the smart dimension and finish the dimensioning part. So you want the center points, so just select the center option, center mark option from the annotation and place it on the circle. You get the center mark for this, the center mark for this circle, correct? So select the smart dimension. So this is equal to 70. The total height will be equal to 50, which will also be shown in the side view. The total depth is 60 mm. So 60 here, and this is 50. And this is having a thickness of 20 mm. Okay. So now show the diameter of this circle, which is 50 mm. And the diameter of this through hole, which is equal to 30 mm. So this is the procedure. And now this is the radii of 10. And this will also be equal to 10. So no need to show that again. So with this, we have completed all the dimensioning also. So in the annotation, select the text symbol, change the font to Times New Roman. So label the views, that is front view, top view. This is the left side view in the right profile plane, and label the planes, that is X and Y. So this is the XY plane, this is X1, and this is Y1, correct? So with this, we have completed the orthographic projections of the given part. So this is the part that we have created. This is the 3D part modeling, and this is the orthographic projection of the created part. Thank you all for watching.